Picture this, a cargo plane so massive it could swallow a football field, tanks with 5 turrets that looked like rolling fortresses, and flying ships that skimmed across water faster than most jets. The Soviet Union didn't just build machines, they built monuments to human ambition that honestly defied every rule of conventional engineering. These weren't just vehicles, they were statements of power, dreams made of steel and concrete that announced to the world that impossibility was just another engineering challenge to overcome. Today we're exploring 10 Soviet creations that, well, redefined what machines could actually accomplish. The discovery that changed everything. The Antonov An-225 Maria was the largest aircraft ever built, so massive that its cargo hold could fit 50 cars with room to spare. This Ukrainian giant measured 275 feet long with a wingspan of 290 feet, powered by 6 turbofan engines that generated enough thrust to lift a fully loaded 747 into the sky. Originally designed to carry the Soviet space shuttle Buran on its back, the An-225 represented the pinnacle of cargo aircraft engineering. Its maximum takeoff weight reached 640 tons, equivalent to 400 average cars stacked together. The aircraft's 32-wheel landing gear distributed this enormous weight across multiple contact points, allowing it to operate from airports that couldn't handle conventional heavy cargo planes. What made the Maria truly extraordinary was its versatility. Beyond space shuttle transport, it carried everything from power plant generators to humanitarian aid supplies. In 2010, it transported the longest cargo item in aviation history, 2 138-foot wind turbine blades from China to Denmark. The aircraft's built-in crane system could handle 33-ton loads, while its pressurized cargo compartment maintained perfect conditions for sensitive equipment. The An-225's operational capabilities were equally impressive. Despite its size, it could reach altitudes of 36,000 feet and cruise at 528 miles per hour. Its range of 9,569 miles meant it could fly from London to Australia without refueling, making it the ultimate global cargo solution. Tragically, this engineering marvel was destroyed during the 2022 conflict in Ukraine, ending the operational life of humanity's largest flying machine and marking the loss of an irreplaceable piece of aviation history. An object unlike anything. The T-35 was the Soviet Union's answer to the question, what if we built a tank that looked like a land battleship? This 5-turreted monster measured 32 feet long, 10 feet wide, and 11 feet tall, making it one of the most imposing armored vehicles ever constructed. Weighing 45 tons and requiring a crew of 11 men, the T-35 bristled with weaponry that would make modern tanks envious. Its main turret housed a 76mm cannon, while 2 smaller turrets carried 45mm guns, and 5 additional positions mounted 7.62mm machine guns. This firepower arrangement meant the T-35 could engage multiple targets simultaneously from different directions, a capability no other tank possessed. The engineering challenge of coordinating 5 separate turrets was immense. Each turret operated independently, requiring constant communication between crew members to avoid friendly fire incidents. The tank's internal layout resembled a cramped apartment building, with fighting compartments separated from each other, and some turrets actually blocking access hatches. Despite its impressive appearance, the T-35 proved mechanically unreliable in combat. During Operation Barbarossa, most T-35s were lost to mechanical failures rather than enemy action. The complex transmission system and underpowered 500-horsepower engine struggled to move the massive vehicle effectively, limiting its operational speed to just 19 miles per hour on roads. Only 61 T-35s were ever built between 1934 and 1939, making it one of the rarest tanks in military history. While it failed as a practical weapon, the T-35 succeeded as a propaganda tool, appearing in countless parades and demonstrating Soviet industrial might to the world. The mysterious hum of The Lund-class Ekranoplan was the only ground-effect vehicle ever deployed as an operational warship, earning the nickname Caspian Sea Monster from confused American intelligence analysts who spotted it on satellite imagery. This 242-foot-long beast could skim across water at 342 miles per hour while carrying 6 anti-ship missiles on its back. Ground effect technology allowed the Lund to fly just 13 feet above water surfaces, using compressed air beneath its wings to create lift. This unique flight envelope made it invisible to ship-based radar systems while remaining too low for conventional aircraft interception. The result was a vehicle that combined the speed of an aircraft with the stealth characteristics of a submarine. The Lund's military capabilities were formidable. Its 6 P-270 Mosquet missiles could engage targets at ranges exceeding 75 miles, while its low-altitude approach made defensive countermeasures nearly impossible. The craft could reach combat zones faster than any surface vessel, while carrying firepower equivalent to a guided missile destroyer. Operationally, the Lund served with the Soviet Caspian Flotilla from 1987 until the late 1990s. Its massive Kuznetsov NK-87 engines borrowed from the Il-86 airliner provided 28,600 pounds of thrust each, enabling rapid acceleration and sustained high-speed flight over water. The program ended when the Soviet Union collapsed, leaving only one completed Lund-class vehicle. Today, this remarkable machine sits preserved on a beach in Dagestan, Russia, serving as a tourist attraction and a reminder of Soviet engineering ambition that, honestly, pushed the boundaries between sea and sky. Buran Space Shuttle. Buran Space Shuttle represented the Soviet Union's most ambitious attempt to match American space technology, creating a reusable spacecraft that could perform fully automated missions without human pilots aboard. This achievement made Buran the first spaceplane capable of unmanned orbital flight and autonomous landing. Unlike NASA's space shuttle, Buran launched aboard the massive Energia rocket, with its main engines remaining on the booster rather than the orbiter. This design philosophy allowed Buran to carry heavier payloads while reducing the complexity of the reusable vehicle. The spacecraft measured 119 feet long with a 78-foot wingspan, capable of delivering 30 tons to orbit and returning 20 tons to Earth. Buran's November 15, 1988 flight demonstrated technological capabilities that NASA's shuttle couldn't match. The spacecraft completed 2 orbits in 208 minutes, performing a perfect automated landing at Baikonur Cosmodrome without any human intervention. This autonomous capability resulted from sophisticated computer systems that could adapt to changing conditions during re-entry and landing. The program's scale was staggering. Over 1,000 companies across the Soviet Union contributed to Buran's development, making it the largest and most expensive project in Soviet space history. The spacecraft featured advanced thermal protection systems, life support capabilities for 6 crew members, and a cargo bay designed for military and civilian missions. Despite its technical success, Buran flew only once before the Soviet Union's collapse ended the program in 1993. The sole operational orbiter was destroyed in 2002 when its storage hangar collapsed, ending the remarkable story of the Soviet space shuttle that proved automated spaceflight was possible decades before modern autonomous systems. The heliopause's shocking. The VDNKH robot emerged from the Soviet Union's ambitious vision of a future where humanoid machines would work alongside humans in industry and daily life. Displayed at Moscow's Exhibition of Achievements of National Economy in 1959, this early humanoid robot captured imaginations and demonstrated Soviet technological prowess during the height of the Cold War. Standing 1.8 meters tall, the VDNKH robot could execute 18 different commands via radio control, including basic movements, gestures, and responses to light and sound stimuli. Its sophisticated control system allowed operators to demonstrate complex sequences that mimicked human behavior, creating an illusion of artificial intelligence that amazed exhibition visitors. The robot's design philosophy reflected Soviet optimism about technological progress. Engineers envisioned a future where such machines would perform dangerous industrial tasks, assist in space exploration, and support human workers in various capacities. The VDNKH robot served as both a technological demonstration and a propaganda tool, showcasing Soviet innovation in emerging fields like cybernetics and automation. Performance demonstrations occurred every 2 hours on a specially constructed stage in front of the electrification pavilion. The robot's ability to see and hear through primitive sensors created an interactive experience that seemed decades ahead of its time. Audiences watched in amazement as the machine responded to commands and environmental stimuli with human-like movements. While primitive compared to modern robotics, the VDNKH robot played a crucial role in Soviet technological development. It inspired a generation of engineers and scientists while demonstrating that human-machine collaboration was not just science fiction, but an achievable goal through dedicated engineering and innovation. The search for alien signals begins. The MAZ 7907 stands as the most extreme truck ever built, featuring 24 wheels, 2 gas turbine engines, and the capability to transport 100-ton intercontinental ballistic missiles across any terrain. This 92-foot-long monster was designed to carry the RT-23 Molodets ICBM, a nuclear weapon capable of reaching targets 6,200 miles away. Engineering the MAZ 7907 required solving unprecedented challenges. The vehicle's 24 wheels were individually powered by electric motors, with electricity generated by twin 1,250 horsepower gas turbine engines borrowed from T-80 tanks. This turbine electric drive system provided the torque necessary to move 150-ton payloads while maintaining mobility across rough terrain. The truck's articulated frame design allowed it to navigate obstacles that would immobilize conventional vehicles. 8 pairs of steerable wheels could turn synchronously for crabbing motion or asynchronously for tight turns, giving the 30-meter vehicle a turning radius of just 27 meters. Independent hydropneumatic suspension on each wheel provided 2 meters of ground clearance while maintaining stability. Only 2 MAZ 7907 prototypes were completed before the Cold War ended, making nuclear missile transport unnecessary. However, the vehicle's capabilities were proven in 1996, when one prototype successfully transported an 88-ton ship 250 kilometers from the Berezina River to Lake Narak in Belarus, demonstrating its practical utility beyond military applications. The surviving MAZ 7907 now resides in a museum representing the pinnacle of Soviet heavy transport engineering. Its unique combination of power, mobility, and payload capacity remains unmatched by any vehicle before or since, proving that Soviet engineers could overcome any logistical challenge when national security demanded it. The 300 mysterious objects discovered. The original Caspian Sea monster, officially designated KM Ekranoplan, was an experimental ground effect vehicle that confused American intelligence so thoroughly they couldn't classify it as either aircraft or ship. This 347-foot-long behemoth represented the Soviet Union's boldest attempt to revolutionize military transportation through radical engineering. Designed by Rostislav Alexiev in the 1960s, the KM used ground effect principles to achieve sustained flight just meters above water surfaces. 10 massive engines mounted on its forward fuselage generated enough thrust to lift the 544-ton vehicle while maintaining speeds up to 460 miles per hour. This combination of size and speed created capabilities that no conventional aircraft or ship could match. The KM's strategic advantages were immediately apparent to military planners. Flying below radar detection altitude while maintaining aircraft-like speeds, it could deliver troops, equipment, or weapons to coastal targets without warning. Its ability to operate over water eliminated the need for runways while providing access to 70% of Earth's surface. Testing revealed both the vehicle's potential and limitations. The KM successfully demonstrated its flight capabilities during numerous test missions, proving that ground effect could support vehicles far larger than anyone previously imagined. However, operational constraints became evident. The craft could only fly safely in calm weather conditions, and saltwater spray caused engine corrosion problems. The program ended in 1980 when pilot error caused the KM to crash during a test flight. Despite its ultimate failure, the Caspian Sea monster proved that unconventional engineering approaches could create entirely new categories of vehicles, inspiring future developments in ground effect technology worldwide. The implications of alien technology. The MiL V-12 helicopter holds the distinction of being the largest helicopter ever built, a twin-rotor giant designed to transport intercontinental ballistic missiles to remote launch sites across the Soviet Union. With rotors spanning 220 feet tip to tip, this mechanical praying mantis could lift payloads that challenged the laws of physics. Powered by 4 massive turboshaft engines producing 6,500 horsepower each, the V-12 generated enough lift to carry 88,000 pounds of cargo to altitude. Its side-by-side rotor configuration eliminated the torque problems that plagued single-rotor heavy-lift helicopters, while providing redundancy crucial for carrying nuclear weapons across vast distances. The helicopter's record-setting capabilities were demonstrated in 1969, when test pilots carried a 40,000-kilogram load to 2,255 meters altitude. a helicopter weightlifting record that remains unbroken today. This achievement proved that rotorcraft could handle strategic cargo missions previously reserved for fixed-wing aircraft, opening new possibilities for military logistics. Operating the V-12 required exceptional skill and coordination. 6 crew members, including a dedicated electrician, managed the complex systems necessary to keep the giant airborne. The helicopter's enormous size created unique handling challenges, with rotor wash powerful enough to damage ground facilities and nearby aircraft. Despite successful testing, the V-12 never entered production. The Soviet military ultimately chose rail-mobile missile systems over helicopter transport, making the massive rotorcraft unnecessary. Only 2 prototypes were built, representing the absolute limits of helicopter technology and demonstrating that Soviet engineers could scale any concept to unprecedented proportions when strategic requirements demanded it.
Tsar tank.
The Tsar tank represented Imperial Russia's most bizarre approach to armored warfare, featuring 2 enormous 27-foot diameter wheels at the front and a small trailing wheel at the rear. This tricycle-like armored vehicle looked more like a giant penny-farthing bicycle than a military weapon, yet it embodied revolutionary thinking about battlefield mobility. Designed in 1914 by Nikolai Lebedenko, the Tsar tank's unusual configuration aimed to solve trench warfare's mobility problems. The massive front wheels could theoretically roll over trenches, obstacles, and rough terrain that would stop conventional tracked vehicles. At 40 feet long and 30 feet tall, the vehicle towered over battlefield obstacles while providing an elevated firing platform for its crew. The tank's armament included multiple machine guns and cannon positions distributed throughout its armored hull. Crew members operated from various levels within the vehicle, with gunners positioned to provide 360-degree coverage. The elevated design offered excellent visibility and firing angles that ground-level tanks couldn't achieve. However, the Tsar tank's first test revealed fatal flaws in its design. The rear wheel, much smaller than the front wheels, immediately became stuck in soft ground, immobilizing the entire vehicle. The massive front wheels, while impressive in concept, created enormous ground pressure that caused the tank to sink into anything softer than concrete. After this embarrassing failure, the Tsar tank was abandoned in the testing area, where it remained until 1923. Despite its impractical design, the vehicle demonstrated Russian willingness to pursue radical solutions to military challenges, establishing a tradition of unconventional thinking that would characterize Soviet engineering for decades.
Tsar tank.
The Bartini-Beriev VVA-14 looked like it flew straight out of a science fiction movie, resembling Star Wars Millennium Falcon 5 years before that film was even made. This vertical takeoff amphibious aircraft represented one of the Soviet Union's most ambitious attempts to create a multi-role vehicle capable of operating from land, water, or aircraft carriers. Designed by Italian-born engineer Roberto Bartini, the VVA-14 featured an unusual configuration with a central fuselage flanked by 2 large pontoons and multiple lift engines for vertical flight. This design allowed the aircraft to take off vertically like a helicopter, transition to horizontal flight like an airplane, and land on water like a seaplane, all within a single mission profile. The aircraft's intended role was anti-submarine warfare, using its unique capabilities to patrol vast ocean areas while remaining independent of traditional airfields. 14 lift engines mounted in the pontoons provided vertical thrust, while 2 cruise engines enabled high-speed horizontal flight. The combination promised unprecedented operational flexibility for naval aviation. Testing began in 1972, with the VVA-14 successfully demonstrating conventional takeoff and landing capabilities. However, the vertical flight system was never fully implemented due to technical challenges with the lift engines. The complex transition between flight modes proved more difficult than anticipated, requiring sophisticated control systems that exceeded 1970s technology. Only 3 prototypes were built before the program was canceled in 1975. Despite its failure to achieve full operational capability, the VVA-14 demonstrated Soviet willingness to pursue revolutionary aircraft concepts that pushed the boundaries of aeronautical engineering and inspired future developments in vertical takeoff technology. From flying tanks to nuclear-powered trucks, these 10 Soviet machines prove that when engineers are given unlimited budgets and impossible challenges, they create vehicles that redefine reality itself. Each machine represents a moment when Soviet designers looked at conventional wisdom and decided to build something completely different instead. While many failed to achieve their ambitious goals, they pushed technology forward and inspired innovations we still use today. These weren't just machines. They were dreams made of steel and determination. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible stories from the world of engineering extremes. Imagine a moment when humanity's most powerful machine briefly created a microscopic black hole, a tiny tear in the fabric of space-time itself. This happened not in some distant galaxy but right here on Earth, deep beneath the Swiss-French border at CERN's Large Hadron Collider. In recent years, scientists have observed phenomena that could represent the birth and evaporation of micro-black holes, discoveries that challenge our understanding of physics, extra dimensions, and the very nature of reality. Today we dive into what happened after CERN scientists created these quantum black holes. The machine that recreates the Big Bang. The Large Hadron Collider at CERN stands as humanity's most ambitious scientific instrument, a 27-kilometer ring of superconducting magnets buried 175 meters beneath the France-Switzerland border near Geneva. Built between 1998 and 2008 through collaboration with over 10,000 scientists from hundreds of universities across more than 100 countries, the LHC represents the pinnacle of human engineering achievement. This massive machine accelerates protons to 99.9999991% of light speed, creating collision energies of up to 13 tera-electron-volts. Conditions that haven't existed in our corner of the universe since moments after the Big Bang. The LHC's primary mission involves exploring fundamental physics through these extreme energy collisions, most famously leading to the discovery of the Higgs boson in 2012, which confirmed how particles acquire mass. The collider features 4 main crossing points where accelerated particles collide, surrounded by massive detectors like ATLAS and CMS that track the spray of particles created in these violent encounters. These detectors, built like giant three-dimensional cameras made of millions of sensors, can capture the fleeting signatures of exotic particles that exist for mere fractions of a second. The theory behind microscopic black holes. The possibility of creating microscopic black holes at the LHC emerges from revolutionary theories involving extraspatial dimensions beyond our familiar three. Models proposed by physicists Nima Arkani Hamed, Savas Dimopoulos, and Gia Dvali, known as the ADD model, suggest that gravity might propagate through additional hidden dimensions, while other forces remain confined to our three-dimensional space. These theories attempt to solve the hierarchy problem, why gravity appears so much weaker than other fundamental forces. A tiny refrigerator magnet can overcome Earth's entire gravitational pull, suggesting gravity's apparent weakness might result from it spreading through extra dimensions we cannot perceive. If these extra dimensions exist, they would dramatically lower the energy required to create black holes from an impossible 10 to the 19th giga-electron-volts down to potentially just a few tera-electron-volts. Precisely the energy range the LHC can achieve. Under these conditions, when protons collide at nearly light speed, they could concentrate enough energy within a tiny region to exceed the Schwarzschild radius, causing spacetime to collapse into a microscopic black hole. According to Stephen Hawking's theory, such micro-black holes would be extraordinarily unstable, evaporating almost instantly through quantum radiation in roughly 10 to the minus 27 seconds while releasing distinctive particle signatures. The hunt for quantum black holes. The CMS and ATLAS experiments at CERN have conducted extensive searches for microscopic black hole signatures in proton-proton collisions. These searches focus on identifying the distinctive particle sprays that would result from Hawking radiation as micro-black holes evaporate almost instantaneously after formation. The CMS experiment completed comprehensive searches for microscopic black holes produced in high-energy collisions, analyzing data for the characteristic patterns these exotic objects would create. Their detectors look for events where particles converge inward rather than spray outward, consistent with space-time being warped by extreme gravity before the black hole's rapid evaporation. Recent ATLAS collaboration research published in 2023 searched for quantum black holes in electron plus jet and muon plus jet invariant mass spectra using 140 inverse femtobarns of collision data. While no definitive evidence was found, the experiment set important limits on black hole production, ruling out their existence below certain mass thresholds in various theoretical models. The search techniques involve sophisticated pattern recognition algorithms that can distinguish genuine black hole signatures from the background noise of ordinary particle collisions. These advanced analysis methods continue to push the boundaries of what's detectable, bringing scientists closer to potentially revolutionary discoveries. Hawking radiation and instant evaporation. Stephen Hawking's groundbreaking 1974 theory predicted that black holes aren't completely black but actually emit radiation due to quantum effects near their event horizons. This process, which we call Hawking radiation, happens when quantum fluctuations create particle-antiparticle pairs right at the black hole's boundary. One particle falls in, while the other escapes. Now, for microscopic black holes, this evaporation process happens almost instantaneously. The smaller the black hole, the more intense its Hawking radiation and the faster it evaporates. A micro-black hole created at the LHC would exist for about 10 to the minus 27th seconds, an almost incomprehensibly brief moment during which light can barely travel the width of a single proton. During this fleeting existence, the black hole would release its entire mass energy as a burst of particles, creating a distinctive signature that, in principle, sophisticated detectors could potentially observe. The evaporation would produce a specific spectrum of particles including quarks, gluons, photons, and possibly even some exotic particles not found in the standard model. This rapid evaporation ensures that any micro-black holes created at CERN would be completely harmless, disappearing long before they could interact with surrounding matter or, grow larger through accretion. Evidence for extra dimensions. The detection of micro-black holes would provide, honestly, the first experimental evidence for extraspatial dimensions, fundamentally revolutionizing our understanding of reality's structure. The Arkani-Hamed-Dimopoulos-Dvali model and Randall-Sundrum scenarios propose that our universe contains additional spatial dimensions beyond the three we experience directly. These hidden dimensions would be compactified, curled up so tightly at every point in space that we just can't perceive them in everyday life. Imagine for a second an ant walking along a garden hose. From far away the hose looks one-dimensional, but up close, the ant can move around its circumference through an extra spatial dimension. If gravity propagates through these extra dimensions while electromagnetic weak and strong forces remain confined to our familiar three-dimensional space, it would explain why gravity appears so much weaker than the other fundamental forces. The precise energy threshold for micro-black hole production would actually reveal the number and size of these extra dimensions. Recent theoretical work suggests that observing micro-black hole evaporation patterns could provide detailed information about the geometry of extra dimensions, potentially mapping aspects of reality that have remained hidden since the universe's beginning. This would represent, without exaggeration, one of the most profound discoveries in the history of physics. The search continues with advanced technology. CERN's search for micro-black holes employs, honestly, some of the most cutting-edge detection technology and analysis techniques that really push the boundaries of experimental physics. The ATLAS and CMS detectors surrounding collision points contain millions of sensors arranged in layers, creating three-dimensional snapshots of particle interactions with unprecedented precision. Machine learning algorithms now analyze collision data, searching for subtle patterns that might indicate micro-black hole formation and evaporation. These AI systems can process vast amounts of data far more efficiently than human researchers, identifying anomalies that might otherwise be missed in the background noise of ordinary particle collisions. The CMS experiment's search for microscopic black holes has set increasingly stringent limits on their production, ruling out their existence up to masses of 3.5 to 4.5 TeV in various theoretical models. Similarly, ATLAS collaboration research has pushed these limits even higher, with recent studies excluding quantum black holes below 9.2 TeV in the ADD model and 6.8 TeV in the Randall-Sundrum model. As the LHC undergoes upgrades toward its high luminosity phase, planned to begin operations in the late 2020s, the increased collision rate and improved detector sensitivity will provide even more opportunities to search for these elusive quantum phenomena. Connections to dark matter and dark energy. The potential discovery of micro-black holes at CERN could, really illuminate the mysterious dark sector of physics which actually makes up about 95% of the universe's content. Dark matter and dark energy are still, among the greatest unsolved puzzles in cosmology, and we can only detect them through their gravitational effects on visible matter and the expansion of the cosmos. Some theoretical models even suggest that black hole evaporation might produce particles from the dark sector, which would offer us a unique laboratory window into these invisible components of the universe. If micro-black holes briefly connect our familiar matter with dark matter through quantum effects, then their evaporation signatures could finally reveal the nature of particles that have managed to elude direct detection for decades. Now, primordial black hole theories propose that tiny black holes formed in the early universe could account for some or maybe even all of dark matter. If CERN's experiments are able to produce micro-black holes with evaporation patterns that match theoretical predictions for primordial black holes, that would be honestly pretty compelling evidence for these cosmological models. Additionally, some theories suggest that dark energy's mysterious acceleration of cosmic expansion might be connected to extra dimensions through which gravity propagates. So, micro-black hole production could, in fact, offer indirect evidence for these connections, potentially solving multiple cosmic mysteries at once through a single experimental breakthrough. Quantum entanglement and space-time connections. The creation and evaporation of micro-black holes provides a unique testing ground for the revolutionary ER equals EPR conjecture, which was proposed by physicists Juan Maldacena and Leonard Susskind back in 2013. This groundbreaking idea suggests that quantum entanglement and wormholes, also known as Einstein-Rosen bridges, are actually the same phenomenon, just viewed from different perspectives. According to this theory, when particles become quantum entangled, they're actually connected through these tiny wormholes in the fabric of space-time itself. If micro-black holes form at CERN, their evaporation could produce entangled particles that reveal these quantum connections, potentially providing the first experimental evidence for this profound relationship between quantum mechanics and general relativity. Observing correlated particle decays from micro-black hole evaporation could demonstrate that space-time isn't really the fundamental backdrop against which physics happens, but rather something that emerges from deeper quantum information relationships. This would suggest that the fabric of reality is woven from quantum threads of information, instead of being a smooth, continuous medium. Discoveries like this could address the black hole information paradox, which is this really fundamental problem where quantum mechanics and general relativity seem totally incompatible at black hole boundaries. The data from micro-black hole evaporation might finally reveal whether information falling into black holes is truly lost, or somehow preserved in their radiation. Safety and cosmic ray comparisons. Concerns about creating black holes at the LHC have been thoroughly addressed through comprehensive safety assessments by independent groups of physicists all over the world. The fundamental argument for safety comes from comparing LHC energies with natural cosmic ray collisions that constantly bombard Earth's atmosphere. Cosmic rays from space carry energies up to 10 to the power of 20 electron volts, which is about 10 million times higher than the LHC's maximum energy of 13 tera-electron volts. These ultra-high energy particles create natural collisions with our atmosphere roughly 1 million times per square kilometer every year, and Earth has experienced this kind of bombardment throughout its 4.5 billion year history without any damage at all. If micro-black holes could pose any danger at the energies CERN explores, nature would have already conducted these experiments countless times throughout cosmic history. The fact that Earth and other astronomical objects remain completely intact demonstrates that such phenomena are either impossible or totally harmless. Even if micro-black holes formed but didn't evaporate through Hawking radiation, which would mean Hawking's theory is fundamentally wrong, they would still pose no threat, thanks to their incredibly weak interaction with ordinary matter. They would just pass right through Earth almost without effect, similar to the trillions of neutrinos that pass through our bodies every second, unnoticed. The future of fundamental physics. The potential discovery of micro-black holes at CERN represents a lot more than just confirming some exotic theoretical predictions. It would actually mark the beginning of a whole new era in fundamental physics research. Such discoveries would provide the first experimental access to quantum gravity, the long-sought theory that unifies quantum mechanics with Einstein's general relativity. Understanding how gravity behaves at quantum scales could, honestly, revolutionize technology in ways we can barely even imagine, maybe leading to new forms of energy generation, propulsion systems, or even manipulation of space-time itself. The knowledge gained from studying micro-black hole evaporation could also inform our understanding of the universe's earliest moments, as well as its ultimate fate. As CERN prepares for the high-luminosity LHC upgrade and looks ahead to even more powerful future colliders, the search for micro-black holes will continue with unprecedented sensitivity and precision. Every single collision brings us closer to potentially revolutionary discoveries that could reshape our understanding of reality's most fundamental nature. The journey into quantum gravity and extra dimensions is humanity's boldest exploration of the cosmos, probing the deepest mysteries of existence through the power of human ingenuity and international scientific collaboration. Whether or not micro-black holes actually exist, the search itself advances our knowledge of the universe's most profound secrets. CERN's quest to create and study micro-black holes really does represent humanity's boldest attempt to understand the fundamental nature of reality itself. Whether these quantum phenomena exist or not, the search has already pushed forward our knowledge of particle physics, extra dimensions, and those deep connections between quantum mechanics and gravity. As scientists keep pushing the boundaries of what's possible, we're standing on the threshold of discoveries that could transform our understanding of space, time, and matter forever. Thanks for watching Stellar Tech, and don't forget to subscribe for more groundbreaking discoveries from the frontiers of science. The Soviet Union's 30-year obsession with Venus reveals a story of ambition, failure, and unexpected discovery. Between 1961 and 1984, Soviet Venera missions braved scorching heat, crushing pressure, and toxic clouds to study Earth's mysterious twin. Despite harsh conditions that melted lead, these probes did more than survive. They captured the first images from another planet's surface and sent back vital atmospheric data. But what did they really find? Was there life, or was it all a mistake? Today, we dive into the Soviet Venus missions and unravel their incredible legacy. The first attempts. The Soviet space program turned to Venus when Mars seemed too difficult to reach consistently. February 12, 1961 marked the launch of Venera 1, the first Soviet attempt to probe our neighboring planet. The spacecraft lost telemetry just 7 days after launch and drifted silently toward Venus, never transmitting data upon arrival. Venera 2, launched in November 1965, suffered a similar fate when its communication systems failed after leaving Earth orbit, but the Soviets refused to give up. Venera 3, launched on November 16, 1965, became the first human-made object to impact Venus on March 1, 1966. Though it crashed without sending back any information. The breakthrough came with Venera 4 in June 1967, which successfully entered Venus's atmosphere and transmitted the first chemical analysis back to Earth. The probe revealed a dense hostile atmosphere composed of 90 to 95% carbon dioxide with crushing pressure and searing temperatures. Despite failing to reach the surface intact, Venera 4 proved that spacecraft could survive entry into another planet's atmosphere and paved the way for future missions to probe Venus's sulfuric acid clouds and scorching surface. First surface success, Venera 7, launched in August 1970, achieved what many thought impossible: the first successful soft landing on another planet's surface. The probe endured surface temperatures exceeding 465 degrees Celsius and atmospheric pressure 90 times greater than Earth's. For 23 precious minutes, Venera 7 transmitted data from Venus's hellish surface, providing the first direct measurements of conditions on another world. The mission was led by Soviet engineer Georgy Babakin, who had designed the spacecraft to be massively overbuilt to ensure survival. The probe's parachute partially failed during descent, causing it to topple over upon landing, but its robust construction allowed it to continue operating despite the mishap. This groundbreaking achievement proved that spacecraft could not only survive Venus's extreme environment, but also function long enough to send valuable scientific data back to Earth. The temperature and pressure readings confirmed what earlier atmospheric probes had suggested. Venus was a world of extremes where nothing resembling Earth life could possibly survive. Yet the successful landing opened the door for more ambitious missions that would soon reveal surprising discoveries about our planetary neighbor. First images from hell. October 1975 marked a historic breakthrough when Venera 9 and Venera 10 became the first spacecraft to successfully transmit images from another planet's surface. Venera 9 landed on October 22, 1975, followed by Venera 10 3 days later. The black and white photographs revealed a rocky, barren landscape covered in volcanic basalt formations and scattered angular boulders. The images contradicted earlier assumptions of a uniformly smooth, dust-covered surface, instead showing a world with surprising geological diversity. Each lander carried a suite of instruments designed by Soviet scientist Mikhail Marov that detected sulfur compounds and evidence of ongoing volcanic activity, suggesting Venus remained geologically active. The harsh atmosphere posed immense engineering challenges, but both probes exceeded expectations by operating for 53 minutes and 65 minutes respectively, far longer than their designed 30-minute lifespans. The images showed flat bedrock surfaces with loose regolith and revealed that despite the crushing atmosphere, substantial amounts of sunlight reached the surface. These missions fundamentally changed our understanding of Venus from a mysterious cloud-shrouded world to a dynamic volcanic planet with complex surface features that continue to intrigue planetary scientists today. Color and chemistry. The 1982 launches of Venera 13 and Venera 14 really represented the pinnacle of Soviet Venus exploration technology. For the very first time in history, color images were transmitted from another planet's surface, revealing this orange-brown terrain bathed in the eerie glow of Venus's thick atmosphere. Venera 13 operated for a record-breaking 127 minutes on March 1, 1982, while Venera 14 functioned for 57 minutes on March 5, 1982. These missions were overseen by Soviet planetary scientist Roald Sagdiv, who later became director of the Space Research Institute. Chemical analysis revealed surface compositions similar to Earth's basalt, but with some intriguing differences. Both landers detected evidence of layered rocks and possible erosion patterns that seemed impossible without liquid water. Yet Venus had been bone dry for billions of years. The X-ray fluorescence spectrometers found concentrations of potassium, uranium, and thorium in ratios similar to volcanic rocks on Earth, suggesting Venus had undergone planetary differentiation just like our own world. These discoveries sparked intense debates about Venus's geological past and raised puzzling questions about how sedimentary-like features could form in such an arid, hostile environment. The missions really deepened the paradox of how Venus transformed from a potentially Earth-like world into a scorching wasteland. Balloons in the clouds. December 1984 brought the most ambitious Soviet Venus missions yet, Vega 1 and Vega 2, which combined atmospheric balloons with surface landers in an unprecedented dual approach. The balloon components, developed under the leadership of Soviet engineer Vyacheslav Lincoln, were designed to float at about 53 to 54 kilometers altitude in Venus's middle atmosphere for extended periods. Vega 1's balloon operated for 46 hours, while Vega 2's functioned for 60 hours, drifting approximately 11,600 kilometers and 11,100 kilometers respectively through Venus's turbulent skies. The balloons revealed Venus's atmospheric dynamics to be far more complex than simple greenhouse heating models had predicted. They detected violent wind turbulence, sudden downdrafts of 1 to 3 kilometers, and unexpected convection patterns that really challenged existing theories about planetary atmospheres. Meanwhile, the lander components analyzed surface composition using gamma-ray spectrometers, and discovered that Venus's lower cloud layers likely contained phosphoric acid, rather than just sulfuric acid. The atmospheric data showed that Venus's climate system involved intricate interactions between surface heating, cloud formation, and global wind patterns. These Vega missions pushed the frontiers of planetary meteorology and atmospheric chemistry, providing insights that continue to influence climate models for both Venus and Earth today. The life controversy. In 2012, Russian scientist Leonid Sanfomality from the Space Research Institute made headlines by claiming he had discovered signs of life in 30-year-old photographs from Venera 13. Sanfomality analyzed the images using modern digital enhancement techniques and identified several objects that appeared to move between photographs taken just minutes apart. He suggested these moving objects, which he dubbed Disk, Black Flap, and Scorpion, might represent primitive life forms adapted to Venus's extreme environment. The scientific community, though, reacted with intense skepticism. NASA astrobiologist David Grinspoon and other planetary scientists quickly pointed out that the apparent movement could easily be explained by image processing artifacts, shifting debris, or maybe even mechanical parts from the lander itself falling into view. The surface temperature of 462 degrees Celsius, and crushing atmospheric pressure make it virtually impossible for any known form of life to survive. Some Russian Venera probes had indeed detected particles in Venus's lower atmosphere about 1 micron in length, roughly the size of bacteria, but these were most likely dust particles or atmospheric aerosols rather than biological organisms. While the controversy generated significant media attention, the scientific consensus remains that Venus's surface conditions are far too extreme to support any form of life as we understand it. Scientific legacy. The Soviet Venera program, achieved an unprecedented string of planetary exploration firsts that fundamentally transformed our understanding of Venus. Venera 3 became the first human-made object to reach another planet's surface. Venera 4 performed the first atmospheric analysis of another world. Venera 7 achieved the first successful planetary soft landing, and Venera 9 transmitted the first images from another planet's surface. Between 1961 and 1984, the Soviets launched 28 Venus missions, with 13 successfully entering the planet's atmosphere and 10 reaching the surface. The program's success rate honestly improved dramatically over time, with later missions like Venera 13 and the Vega probes operating far beyond their design specifications. The data collected revealed Venus as a world of extremes: surface temperatures hot enough to melt lead, atmospheric pressure equivalent to being 900 meters underwater on Earth, and clouds of concentrated sulfuric acid. These discoveries showed that despite Venus's similar size and mass to Earth, the two planets had evolved along completely different paths. The Venera missions demonstrated that robotic exploration could achieve remarkable scientific discoveries at a fraction of the cost of human missions, establishing templates for planetary exploration that continue to influence mission design today. The Soviet achievement to this day remains unmatched. No other nation has successfully landed on Venus since 1984. The search for ancient oceans. Recent analysis of Venera and Vega data has, really renewed scientific interest in Venus's mysterious past. The atmospheric measurements revealed deuterium to hydrogen ratios, suggesting Venus once possessed substantial water oceans that gradually escaped to space over billions of years. Venera 12 detected lightning activity in 1978, indicating ongoing atmospheric dynamics that might preserve clues about the planet's watery past. The surface composition data from multiple landers showed evidence of granite-like rocks that on Earth typically form through water-mediated processes, raising some pretty intriguing questions about Venus's geological history. Soviet atmospheric chemist Mikhail Zolotov later proposed that Venus might have remained habitable for up to 2 billion years after formation, potentially long enough for life to evolve before the runaway greenhouse effect took hold. The phosphine detected in Venus's upper atmosphere by Earth-based telescopes in 2020 has reignited debates about possible microbial life surviving in the planet's clouds, though this remains highly speculative. While the Venera missions found no direct evidence of life, their comprehensive atmospheric and surface data continue providing crucial insights into planetary evolution and the conditions necessary for life to emerge and survive in extreme environments. Engineering marvels. The engineering challenges overcome by Venera spacecraft represented, honestly, some of the most impressive technological achievements of the Cold War space race. Each lander had to survive a journey of over 100 million kilometers through space, then endure entry into an atmosphere 90 times denser than Earth's, all while maintaining structural integrity under crushing pressure and corrosive conditions. Soviet engineer Georgy Babakin's design team developed specialized materials and cooling systems that could function in temperatures exceeding 450 degrees Celsius. The landers used titanium pressure vessels and thermal insulation systems that pre-cooled the internal electronics before landing. Venera 13 and 14 employed spring-loaded mechanisms to eject protective lens caps and deploy soil sampling arms in the hostile environment. The Vega balloons represented even greater engineering complexity, requiring altitude-controlled floating platforms that could survive sulfuric acid clouds while maintaining radio contact across interplanetary distances. Communication systems had to penetrate Venus's dense atmosphere and transmit across millions of kilometers back to Earth, using only limited battery power. The success of these missions demonstrated Soviet technological superiority in planetary exploration during the 1970s and 80s, achieving engineering feats that remain impressive by today's standards and inspiring current Venus mission concepts being developed by NASA and other space agencies. Modern revelations. Contemporary analysis of Venera data using modern computational techniques, continues revealing new insights about Venus's evolution and its potential for past habitability. Computer models based on atmospheric measurements from Venera 11, 12, and the Vega probes suggest Venus might have maintained liquid water oceans until as recently as 715 million years ago, much later than previously thought. The surface composition data collected by multiple landers indicates Venus underwent extensive volcanic resurfacing within the past 500 million years, potentially erasing evidence of earlier, more temperate conditions. Recent studies of the phosphine signatures detected in Venus's atmosphere have prompted renewed examination of Venera atmospheric data, though no definitive biosignatures have been identified. NASA's planned Veritas and Da Vinci Plus missions will build directly on Soviet discoveries, using advanced spectrometers and imaging systems to investigate the tantalizing clues left by the Venera program. The Soviet Venus missions established that, while the planet's surface remains utterly hostile to life as we know it, its atmospheric chemistry and geological history contain important secrets about planetary evolution. These missions proved that systematic robotic exploration could unlock the mysteries of even the most forbidding worlds, setting the stage for future discoveries that may finally answer whether Venus ever harbored life. The Soviet Venera and Vega missions transformed our understanding of Venus from a mysterious, shrouded world to a dynamic volcanic planet with a complex atmospheric system. They achieved humanity's first images and chemical analysis from another planet's surface, establishing crucial foundations for all subsequent planetary exploration. Though no definitive signs of life were discovered, these pioneering missions revealed a world with a rich geological history and atmospheric complexity that continues to intrigue scientists today. Subscribe to Stellar Tech for more deep dives into space exploration's greatest achievements, where scientific truth meets human curiosity and, discovery awaits.